Hi, welcome to this demonstration of automated business logic integrated with Vaadin. We'll be illustrating a target order entry application where there's customers, orders, and items. And what we're trying to do is make sure that the roll-up of the order items into the purchase order into the customer does not exceed the credit limit. So here's our application, customers, their orders, and their items. This interface was chosen to illustrate the effects of the business logic as well as possible. Business logic places no constraints on what your interface is. This interface also enables us to do lots of use cases that are related to the same bit of logic. For example, we might decide to pay off this order. I'll watch this customer's balance when I save. Conversely, we might wish to, another transaction or use case that affects this same data is if I try to buy lots of items or increase my quantity. And we'll see that that fails with the expected and planned for constraint that my roll-up of the items to purchase order to a customer's balance exceeds that customer's credit limit. The application was built by Vaadin in the usual way. In this case, we use the JPA container. Let's take a look at how we define the business logic. And in particular, how do we define it so that it was shared, not in a controller, but also it can be shared between controllers and, in fact, between service or message-based transactions. We said earlier this application is about customers, purchase orders, and line items. And the sort of business requirement or objective is that we check the credit limit. We can state that more formally by these rules here, perhaps uncovered in a joint application design session by IT talking to business users. And the first thing they might say, the business users might say is, well, you have to make sure that the balance is less than the credit limit. So we've defined that here in our business logic. First of all, let's give a little bit of understanding of the application. The application has the JPA beans defined here. Here's where the user interface is defined. That's the Vaadin code that you write. And here's the business logic itself. And what we see is that there's a logic file corresponding to each of the domain classes. And we're going to look at those now. And in particular, we look at the customer logic. So the constraint, balance less the credit limit, we've stated a little bit more fancy here in the example so that you can see that rules can support if-then-else logic. But the way this works is, again, you have this logic class. These annotations define rules. This particular rule is a constraint, and that's how we define our first rule. Alternatively, we could have entered exactly this into the annotation. But we, again, as we said earlier, wanted to show about if-then-else and so forth. So the second rule might say, well, that's good. What is the balance? The stepwise definition of terms that so often is typified in analysis. And the business users might say, well, that's the sum of the orders total for the orders that are not already paid for. And that's this rule right here, again, identified by the annotation. So this says purchase orders, that's the customer's related purchase orders, summing the amount total attribute where paid is false. Worth noting, this is not a SQL sum. There's very important adjustment optimizations apply to this that we'll talk about later. So that defines how we derive the balance. Another important characteristic of rules is that they forward chain and they reference each other, not unlike a spreadsheet. So this attribute here is defined here. So now we have to ask the question then, where's order total? Or what is order total? How is that defined? Business users might say, well, it's the sum of the line item amounts. So that's logic for the purchase order. And it's defined just as we saw earlier, it's the sum of the line items dot amount. So essentially, what we're seeing is we're directly entering our specification, and it's actually executable. Finally, we ask, well, what is the line items amount? And that's the quantity times the price. So that's line item logic, and that's shown right here. And finally, where does the price come from? That's an initial copy of the product price. And that's all the rules it takes to define all of the use cases we saw, and even use cases we didn't see, like deleting an order, reparenting an order from customer 1 to customer 2, choosing a different product for the line item. All of the relevant use cases, are automated by this simple set of rules. So let's have a quick look at the architecture by which those rules are actually executed. As the developer, again, you do two things that we quickly looked at. You define a Vaadin application with the model and the controller, and you define the rules that we just looked at. When the application runs, the Vaadin framework and it calls your controller on button clicks and form starts and so forth, and your controller uses existing JPA APIs, in this case the JPA container issues these APIs, to Hibernate, in particular the JPA version of Hibernate. And the way it works is business logic, just a jar file, plugs into Hibernate events, in particular update events. They monitor them, looking for domain objects that have corresponding logic files. When they're encountered, the system loads the logic file and analyzes it for dependencies to determine ordering. It analyzes the transaction to understand what pruning and optimizations might be enforced, and then executes the rules in a proper and efficient order, no matter what your use case was. In other words, the system has encapsulated the rules into the domain objects via these events, so that your logic can safely be presumed to run for all changes. Automated business logic provides significant benefits for your organization. First is agility. The 5 rules we saw in the demonstration replaced fully 500 lines of code. We know this because we built them and we provided copies of them on the website so you could have a look at them. That's 50% or more of your development effort for database-oriented web apps. In addition, while this was a very simple application, automated business logic is extensible. You can write rules in Java or Groovy, providing if-else logic, and utilize your IDE's editor, debugger, and logging. You can also use Java or Groovy to provide new rule types, and we've used these, as also shown on our website, to automate high-end complexity transactions such as a bill of materials explosion, or the application of a payment to a set of outstanding orders. The agility benefit of return on investment extends to total cost of ownership. First, the transparency of the rules that can be spun out for reports enables your business users to connect with the actual implementation and engage with IT to reduce requirements risk. Rules are automatically reused across use cases, so this guarantees compliance and safeguards your data. Rules are automatically ordered. This helps automate maintenance, since the bulk of maintenance effort is really the archaeology of understanding the ordering of the existing logic so as to make changes that are correct. With automatic ordering, all you do is change the rules and the system reorders the logic based on the new dependencies. These are discovered at execution time, not by code generation, by a combination of introspection and bytecode analysis. Finally, the system provides extensive enterprise optimizations. We mentioned earlier how the sum rule is actually an adjustment. It's not a SQL sum. There's extensive pruning based on the analysis of the incoming transaction, and you can read more about these on the website. So that's a quick look at automated business logic. You can read more about it on the website and download a copy. We'd love to hear from you. Thanks very much for your time.